Um, mm, yep, let's go. So, where are we today? I guess I forgot to turn on one light. One minute. Cool, 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 cool. Hello, guys. MDN. Where did we leave yesterday? Um, JavaScript guide. We did an introduction. Yeah. Uh, are there subsections in introduction, or we did it full? Yep, we did this. So, uh, yep. So grammar and types. I guess we did grammar and types too. Yep, we did grammar and types. So control flow and error handling. Let's just be sure. Yep, yep, yep. I remember this. Um, we did literals and we did hoisting yesterday. So control flow and error handling. Okay. Uh, from what I know, there's try catch block and you can throw it out. So let's see block statements. Obviously, uh, everything in this curly braces is a block. The curly braces form a block, and uh, these statements are grouped. Basically, if I want to describe like block statement, what they do is whatever you can't like if write in a single statement, if you then block basically creates a single statement out of a multiple statement, because if you take this while loop, you can only put just one statement here, but after adding a block you basically uh, make it in such a way that it is seeing this as one uh, whole bigger let's say task. So let's just see what they have written. JavaScript supports a compact set of statements, specific control flow. JavaScript reference. And yeah, the most basic statement is a block statement, which is a group of statements. Exactly, a block is defined in a pair of curly braces. Why declared variables are not block scope? Actually, they are functional scope, uh, and the effects that affects the setting them persist beyond the block itself. Conditional statement. Okay, if else we know from like other languages, it's basic best practices. Uh, in general, a good practice is always use block statement, especially when nesting ifs. Yep. In general, it's a good practice not to have if else with an assignment exist. Okay, obviously. Uh, like this will always return true, so that doesn't help us anyway to compare. Okay, so interesting. Uh, where is it? Where are they doing assignment as a condition? Yep, I get what they are doing. Okay, they are like better way. Basically, they are getting a iterator and getting the next node from the iterator. So obviously this helps, but a better way would be to check if it is the last node. It has like the next node, and then uh, like current node is goes to inside the statement. Where is this? Okay, so we'll come to it. Um, Falsy values. The following values evaluate false. False evaluates for undefined null, zero, not a number, empty string. all are false. Examples: switch empty string is a false. Okay. Do not confuse primitive Boolean values true and false with true and false values of Boolean object. Do not confuse the primitive Boolean values true and false with true and false values of Boolean object. Okay, so B would be false. Okay, yes. Okay, so there's an object which is Boolean, and therefore B will return true. Let's just see what this is to confirm. Where do I? Yep. Console dot log. So we'll know no index.js. Yep. So obviously it's an array. So it returns like it returns a boolean value, and like array, it's an array. Let's just try and console it in the browser, because sometimes I know some things in Node are implemented differently than a browser. Okay. Oof, oof. Inspect. Okay, it's an object, obviously. Object and object of prototype boolean. Like uh, it has a prototype that is of type boolean. So uh, like we know like that there are different types of prototypes also. So there's also date prototype. So I think this is something like that. And so b dot, what does proto activity type of object? Yeah. Okay, but yep, it is, the prototype is of boolean, so it's not the regular prototype. That's what I get. Because if let's say we have an object const c is equals to uh, console dot log c. Um, exactly. So its prototype is of prototype object, and its prototype is prototype boolean. So the type of the prototype is different, but uh, basically boolean itself is a prototype, and it has a yep. Okay, cool. Gotcha. Following example, the function check data returns true if the check data. It's alert, switch statements, we know, exception handling. This is something that I'm not aware of a lot, and like it's something that is overlooked a lot. You can throw exception using throw statement and handle them using try catch statement. Throw statement, try catch statement. We'll get to know about them. Exception type. They're just about any object can be thrown in JavaScript. Nevertheless, not all thrown objects are created equal. While it's common to throw numbers or string as error, it is frequently more effective to use one of the exception type specifically created for this purpose. Let's just see. uh, how they are. Okay, so this is the same page. I guess, yep. ECMAScript exception, DOM exception, DOM error. Range error, type error. Okay, these are the error that we get in the console, like whenever we make mistakes. So uh, basically, I wanted to know what are the types of error. These are like script errors, I guess. Now DOM exception, I haven't seen them any time. Yeah, never seen these kind of not from. I haven't worked a lot with DOM also, so that's also a case. But yep, so like I've worked with React a lot, so um, index size error. Okay. Let's move on through expression, through error, through number, through boolean, through to string of this value. Try catch statement. Try try this if it returns. Invalid catch block. Catch ID block. Try throw exception catch. Login as finally block. Try catch finally. Finally will execute all the time. So that's how it works. So try executes when like at the start. If there's an error, catch will execute. Finally will execute in any case. If the finally block returns the value becomes the try catch finally. Try catch. If the basically they are saying if the finally returns anything, that's the final return, barring all the previous returns. So other returns don't matter. Overwriting the return values by the finally block it also applies to exception thrown and rethrown inside the clash block. Nesting try catch nesting is not a big deal because we know like everything can be nested. So we know how if else is nested, and it's easier to catch on to that idea. Error objects, error object. So we can create a new error like this, new error, and the value that we want for that error to be. It can have different values. Let's just see an error so we'll know what all stuff it has. String message stack. What is the stack? Uh, message. stack an error miss object of error object offers a trace of which functions were called. Oh, okay. This is the stack. Makes sense. It's basically the trace of the functions that were called before trying the error. So, and from which line to the file. Uh, why am I not getting a stack? So I'm console the error. Yeah. If I'm not, I throw only C. Do I get that? Yep. Hmm. Hmm. I guess stack must be passed by the script itself. Sometimes development server create problems. So what's the problem? No stack coming for me. So this is the name, this is the message, this is the error. But I only want the stack. This is name, message, stack. But I only want the stack. That's the problem. Probably that's not allowed. That's not how it works. Let's move on. It doesn't matter that much. Loops and iterations, for loop, for statement, for loop repeat until specific condition evaluates. So first, the JavaScript for loop is similar to Java or C for loop. The for statement looks like initialization expression, condition expression, increment expression. Um, we know that from basic programming. So this is how a for statement looks like. Do while statement. We also did this. So and so we did like do while. We did not do this. So a label provides a statement with an identifier that lets you to refer to it elsewhere in your program. For example, you can use a label to identify a loop, then use the break or continue statement to indicate whether the program should interrupt the loop or continue its execution. The syntax of label looks something like this. Label statement, the value of label. Example, mark loop. Basically, they have made a label. But in what case do I use this? Java. Let's see. Alright. Okay. Cool, cool, cool. I guess probably if you have multiple for loops and in some case inside one for loop, if you want to break or continue from the outer for loop, then you can use these labels. Yeah, that sounds like a good case. Let's move on. Break statement. We know what breaks are. Continue. We know what continues are. For in foreign statement iterates, and we have done foreign also. So, but this is something that um, is not what I am very used to. So we'll go through it. Statement iterates a specified variable or over all enumerated properties of an object. For each distinct property, JavaScript executes the specified statement. A for n statement looks as follows. For variable n object statement. Example, the following function takes its argument, an object and an object name. It then iterates over the object's property and returns a string that lists the property name and their values. Function dump props object name results for constant I in object result object name object name. Okay. Okay. Dot I is equals to object of I. Okay. Mm, yep. Basically, for objects, it gives the uh, keys. Keys. Yep. Gives the keys, and then you can get the values. So in O of n, O of one, I guess. Arrays, although it may be tempting to use this for way to iterate array elements and for a statement where return you name of your user defined properties in addition to numerical index. Therefore, it is better to use traditional. Uh, let's just check what does it do. Const AR is equals to 1, comma 2, comma 3, comma 4, comma 7, 6, comma 7, comma 1, comma 2, comma 3. For let x in ARR, what's wrong? Oh, let x in ARR console log x. So, what do we get? Log x. We get the basically the keys. Uh, because arrays are also objects and AR obj A SSS A comma A comma SSS colon. This is how a real programmer tests out stuff. I'm not writing like what I see a lot of YouTubers do, where they write like proper stay like names, and like they write something like this. Uh, Obviously, when you're writing for in a production code base or somewhere, to write, you will write like this, because at that point you want other developers to understand, and what you have written after a long time, when you are even, it could be a case when you are even gone, or you have left that project. But in reality, like when you are testing stuff for yourself, and like you are just talking and explaining it to a friend or explain to an audience, so at that point you don't write like uh, make is equals to for model is model colon Mustang. You write it like, give it random names. So let's go, let's see uh, what we got. O OBJ. I think we should get SSSA, but nah, mm, I should have haven't done this. BBB and let's say LLL. Yep, SSSA. Are JavaScript objects uh like in are JavaScript objects ordered? No, they are not basically, and not always. So cool. Not always, so they are not ordered. That is for off loop. It gives the values. So for in gives the keys. For off gives the values. So, yep. These are easy topics, and the topics that we have already like done in the beginners, but most of them, so they are just more elaboration on them. I think regex will be something that little challenging, but what's the time? It's almost 11. Did I close YouTube? Yep. What? 30 minutes? Hmm. So we know what functions are. Function declaration we have done. Uh, we have done all the three types of functions basically. So these are named functions. So one function we did was like this: function A, and probably some args, and the code. So console dot log. I hope it goes into console. So let's call this a with comma comma um this, yep. So this is one type. Second type that we did was let a equals to function, and this should work the same. And the third type we did was arrow functions. So these are something like this. So the same. My car make Honda of cons function expressions. Exactly, these are function expressions. And what were those called? Name function, I guess. Named function, function expression, and arrow function. Calling functions, we know that. Function scope, we know that. Scope of functions stack. This recursion. Mm, A function can refer to itself and call itself. The function name, recursion, bar, argument, call. Who is equals to function bar. Within the function body, the following are equivalent. Bar, calling is bar, calling foo, and arguments callee. Um, what is this? Okay, it calls the current executing function. Is there a use for this? No. A function that calls itself is called a recursive function. Exactly. While they are transforming a while loop into a recursive loop. I guess, yep. So it starts with 0, and the first time it goes, it's 0, it's not greater than 10, so the second function is called. And so if you see the stack, it goes on top to the of the stack. So this was the function. It called another function with the value of 1, so that's the function. And then the stack progresses, and after it reaches 10, no 11, uh, 10 actually, because it becomes is equals to 10, it returns. So that top level function from the stack will go away, and the function will start like be removed one by one. So they'll be returned one by one. Well, some algorithms cannot be simply iterative loops, but these are actually nested functions and closures. Nest the function within if a nested function is private and it's containing outer function. The form it forms a closure. A closure is an expression, most commonly a function that can have a free variable together with an environment that binds those variables that closes the expression. Since the nested function is a closure, this measures that nested function can inherit the arguments and variables of containing function. In another word, the inner function contains the scope of the outer function. So we know, like taken in a logical sense, where we know that uh, every inner block will have the uh, uh, variables that are in the outer block. And if you just keep this in mind, closures are very easy to understand because these they are basically the same. That even if you call the inner block somewhere else, uh, but obviously they have the code of the outer block with them. So let's say add squares a and b. So then function square. So uh, basically, yep. So A and B are here, and then they are squaring both A and B. This is not a good example for closure. So because we know that obviously if they are putting the arguments here, uh, we'll get that. But if it was something like A into B, then you could understand that how closures are working. Exactly, this is a good example for closure. So this is a good example of nested functions, and this is a good example of closure where uh, there's an outside function, there's a function that's inside, and it returns x plus y. So, and the inside function is returned. So when we can call the outside function, which will return the inside function because of this, and then we can call the inside function. So this is basically called function currying, and because we are uh, dividing this value into multiple values, and that's why we'll return it. And this can also be called in such a way where we are calling the outside function and that's returning the inside function, and then that inside function is being called. Preservation of variables. Notice how x is preserved a inside and when inside is returned, a closure must preserve the arguments and variables in all scope it references. Since each call provides potentially different arguments, new closure is created for each call outside. The memory can be freed only when returned inside and no longer accessible. This is not different from storing references in other objects, but is often less obvious because one does not set references directly and cannot inspect them. Multiply nested functions. Function can be multiplied nested. For example, a function A contains a function B, which itself contains a function C. Both functions B and C form closure here, so B can access uh, A and C can be accessed B. So closures can be multiply nested, and that's what they are saying, telling. So not a big deal. Ideally, they should like should they return? They are just calling it by like not. Uh, they are calling it normally. They are not making new functions for it. That's not a use case for it. This is not used for this purpose. But yeah, for example, I understand what they are doing. Why they are doing. Name conflicts. So when there are name conflicts, the inside function uh, there is no name conflict here. Okay. It's taking an argument x, so the inside arguments overshadows the outside arguments. So uh, basically, this should return as 20 instead of 10. Exactly. So basically, outside is called, and as outside is called, x is 10 for the outer context and for the inner context, but then x for the inside, then we put x is equals to 10, so 20 is enough. Basically, this inner function x value of x overshadows this inner value of x overshadows the outer value of x. This is called as shadowing. Closures again. We did closures. So closures are not one of the most powerful features of JavaScript. JavaScript allows for nesting of function and grants for inner function full access to all the variables and function defined inside and outside the outer function and all other variables function that the outer function has to. However, the outer function does not have access to variables and function defined inside the inner function. That makes completely sense because uh, we know how scope is passed like through upper scope to lower scope, so we know the hierarchy it works with. This provides a sort of encapsulation for variables of inner function. Yep, so closures can be used, though it's not a very good idea to use them for data hiding because um, are they giving an example? So let's say we want to create an animal. Um, like const animal is equals to a function and it takes lex, let's say lex, and okay, and now we return function name. Let's console.log um, mm, name as lex lex. So now if we call like if we make an animal, so let dog is let four leg four leg animal is equals to animal of four, and now we can like that thing is the variable legs is encapsulated. Now we can easily make let cat is equals to four leg animal. Uh, cat. Same, let's do with a dog. And we'll see the console. Cat has four legs, dog has four legs. Yep. So that's how we can encapsulate stuff. What are they doing? Function get name, return. Exactly, they are doing a very similar thing. So using the argument object. The arguments is of a function are maintained in an array-like object within the function, you can address the argument passed in as follows. I is the ordinal number of arguments started. Oh, what? Okay, this is kind of weird. This is, I don't know if it's weird or. Hmm. Ah, actually, it means what? It dance elephant. Yeah, I would not use this, but I do understand why they are. But how I use this is how I do such kind of stuff is instead of I just spread args and then I do args. So that's how I basically this takes all the arguments and bundles them into an array. But as they say, the argument already has an array. So um, I guess it's kind of cool, but kind of useless also. Because why? This is actually better because now I can easily like start it with zero, which is something very much more, let's say, conventional and easier to do. So I, I get the answer, correct answer. I hope so. Is it console logging that? Nope. Why aren't there any logs? Hmm. So we get the correct answer, but and I think this is a better way, in my opinion, because it's much more explicit, uh, and like a lot of people know about this. So having this functionality does not makes a lot of sense to me. There are two special kind of parameter syntax: the default parameter and rest parameter. The default parameters, uh, these are the default parameters. These are the rest parameters. So A is default, B is default, A is rest. No, no, no. Okay. So okay. So all of them are default parameters, I guess. Uh, However, in some situation it might, and you can all of them are default parameters, default to undefined, and then we can set it up to like one or two and define it. So if we only pass, let's say, A in this, so B will be 1. But if we only pass A in this, then B will be undefined. So, and then we can do this to get the rest of the parameters which are not mentioned. Arrow functions, we talked about that. No separate this. Until arrow functions, every new function defines its own this value, a new object in case of a constructor and define in strict mode function calls the base object if the function is called as an object method, etc. This proved to be less than ideal with object-oriented style of programming. Okay, function person desktop person is equals to 0. They are calling a function which does this .h++, but it has a completely new this, so it doesn't help us a lot. Okay, correct. In non-strict mode, the grow-up function defines this uh, as a global object, which is different from this defined by person constructor. So what will be the value of age after this? Let's just look at this. Should it be in, yep, not number. Yep. It's actually not a number. And because it does not affect this age, it's a new, completely new age. It's a new age. Mm. And now we are uh, a bound function created to be created only over this one. For arrow functions don't have their own this, so it refers to the this of the closest object. Arrow function does not have its own this value of the enclosing execution context is used. Thus, the following code this written in the function that is passed in set interval has the same value this as the enclosing function. Predefined functions. Eval method evaluates Java code represented as string. Eval okay. It's very self-explanatory, but cool, kind of cool. Is finite. A global is finite function determines whether the passed value is a finite number. If needed, the parameter is first converted into a number. The global is finite function determines whether the passed value is a finite number. Div x is a finite 100 divided by x. Return number is not infinity. Okay. Okay, cool. Checks for infinities. Not a number is not a number. Let's just see it. Uh, Search. Strings are not a number because f is there, but this is a number because this is the scientific notation. Pass, load, pass, and decode URI. Decode URI component method decodes the uniform component previously created by. Okay, just like Okay, the code URI does on all everything. Hmm. Let's just see. Console.log the core URI of this value. Okay, that wasn't expected, but let's do the core URI component. I thought the code URI was a minute. Hmm. I'm what was the string? Let's console log that too. So it's easier to see. So decode URI did nothing. So let's do the same for the other string. Bruh, select fam. Let's see what's the answer for this. It's Greek. Yup. Okay, so decode URI works if everything is encoded, and decode URI component works on like uh both, I guess both. So I guess decode URI component is something that might be used a lot. Decode URI might be like a very niche thing, probably for some examples like this, and code is the opposite. Mm, escape. It's a deprecated method. Computes a new string which contains character that has been replaced by hexadecimal. Ah, unescape, deprecated. Ah, 1 hour is enough. Expressions and operators. This is not a very. Hmm, we'll do this tomorrow. There's a closures again. So some interesting stuff to come. We'll start from expressions and operators tomorrow. Thank you guys. Bye bye.